Hello everybody, it's Mrs. Pound, and we are starting a new chapter, Chapter 7, on chemical bonds from BJU Chemistry's 5th edition. The first topic we're going to talk about is from section 7.1 on bonding basics. So our objectives today are to explain why atoms bond, compare covalent ionic and metallic bonds, and explain the relationship between electron location and polarity in polar covalent bonds, and predict the type of bond that will form between two atoms when given their location on the periodic table. So first of all, what is a chemical bond? It is a durable electrostatic attraction that forms between two atoms. So when we talk about electrostatics, we're talking about opposite charges attracting one another. That's what electrostatics is. Think even of static electricity. Static electricity is caused by the charge separation. Atoms bond to gain stability and lose energy. Much like this pile of rocks that looks very unstable, the higher you go, the farther the electrons are from the nucleus of the atom, the more unstable they are. So they want to be closer to the center of the atom and become more stable. Chemical bonds between atoms involve the rearrangement of electrons to maximize stability. Stability is greater and energy is lower for bonded atoms. And an atom becomes more stable by bonding with another atom if the resulting electron configuration is more like that of a noble gas. So the reason when we talked before about valence electrons and metals wanting to give up valence electrons is because if they shed a shell, the resulting electrons are closer to the nucleus. Also remember that if we go more towards the noble gases, because there's more positive charge in the middle pulling in those electrons, they are also closer to the nucleus. So it has to do with that stability. Because of the fact that they want to be more like noble gases, we have what is called the octet rule. And this is a rule that states that elements are most chemically stable when they have a full valence electron shell, which is typically 8 valence electrons. Now I say typically 8 valence electrons because for hydrogen, it tends to shed it so it has none, and the first few like to be more like helium, which only has 2 because of that whole s orbital thing. So that's why. So note, the octet rule does not apply to the transition and intertransition metals or to the first 4 or 5 elements. To achieve an octet, atoms tend to lose, gain, or share electrons. Atoms with fewer than 4 valence electrons tend to lose electrons, and atoms with more than 4 valence electrons tend to gain electrons. So types of chemical bonds. The first type of chemical bond that I want to talk about is a covalent bond. This is a bond formed by sharing electrons. So I have these two puzzle pieces showing that they are sharing. Now, before we go on, we have to talk about electronegativity. I have to remind you about it. This is the measure of an atom's ability to attract electrons to itself in a chemical bond. And electronegativity is going to predict the bond type. Based on the electronegativities of the elements involved, we can predict which type of bond will be formed. So this most often occurs between two metals because both have high electronegativity values and high electron affinities. Now, ionic bonds are a chemical bond due to the attraction between oppositely charged ions formed by the transfer of valence electrons. This typically involves a metal bonded to a nonmetal because they have very different electronegativity values. Remember, nonmetals have very high electronegativity. Metals have very low electronegativity. And so the nonmetals are more attractive to the electrons and they tend to take them more strongly than the metals. And the atom with the higher electronegativity value takes the electrons from the other atom. There's also metallic bonds. atoms bond by sharing their easily lost electrons among many atoms. The electrons are mobile and not associated with any specific nucleus. And I have a picture of the ocean in the back because it's often described as an electron sea. This is why metals are highly conductive, because the electrons are able to move. There's also the idea of polarity in bonding. This is the tendency of an object to form two localized regions of opposite character or charge. So much like the poles on the Earth, where we have the North Pole and the South Pole, some compounds will show polarity like that when they are bonded. The polarity of a bond depends on the difference in the atom's electronegativities. The greater the difference in electronegativity between two elements, the greater the polarity of the resulting bond. So we can describe covalent bonds two ways. We can have nonpolar covalent bonds where there is equal sharing of atoms between atoms of the same element. And an example is hydrogen, H2. We can see here one hydrogen atom a second. Those two electrons are shared in the middle that they're both donating. So we have hydrogen bonded to hydrogen. So that is nonpolar. In tug of war, they're tugging equally. Neither one is winning. They are sharing, much like those puppies who are about the same size. However, in polar covalent bonds, there is unequal sharing of electrons between atoms of two different elements due to differing electronegativities. And it's more like this unbalanced tug of war where we have 5 versus 3. The bonding electrons spend more time at the end of the bond closest to the atom of higher electronegativity, resulting in a positive and negative pole for the bond. So an example would be hydrogen fluoride. So here, hydrogen is at one end, fluorine at the other. Fluorine is more electronegative, so it pulls the electrons more towards itself. And we have a partial positive charge on the hydrogen and a partial negative charge on the fluorine. So this symbol here, this is a lowercase delta, meaning for difference. And we put a positive to show that slightly positive charge and the slightly negative charge. Also, we can put a plus sign over here to show that this end's a little more positive, and an arrow to show that the electrons are drawn more towards the fluorine atom. Now, as far as polarity is concerned, we can have a purely covalent bond, and that's when it's an atom, the two atoms are the same element, or the atoms involved are the same element. That is a purely covalent bond. But as we work towards the ionic end, we become more ionic. Nothing ever really becomes completely ionic, taking those electrons completely or giving them, but there is a continuum between covalent and ionic. It's not as cut and dry as I make it sound here. There is kind of a spectrum, so to speak, between the two ends. So our objectives were to explain why atoms bond, compare covalent, ionic, and metallic bonds, explain the relationship between electron location and polarity in polar covalent bonds, and predict the type of bond that will form between two atoms when given their location on the periodic table. So don't forget your 5 questions, and I'll be back with more videos about bonding.